Hello guys, welcome to today's another new live stream. We are here to review and discuss about the Leetcode contest 433 and I welcome all of you guys to the stream. Did any of you attend the contest today? So guys, we'll go to the first question of today. Question number 3427. The first question of today's contest. Sum of variable length subarrays. The first question. Sum of variable length subarrays. You are given an integer array nums of size n for each index I where I is greater than 0 but smaller than n. Define a subarray nums start I where start is equal to max of 0, comma I minus nums of I. Return the total sum of all elements from the subarray defined for each index in the array. A subarray, they have given the definition of a subarray. A subarray is a contiguous non-empty sequence of elements within an array. To solve this question, we are gonna use this way. Here the intuition is gonna be like we have to compute the sum of every subarray defined by the array. And for each element, we have to make sure that it's in certain range and it won't go out of the range. And for this, we are going to follow this approach where we'll prefix a sum array. Like we'll use the prefix sum approach and manage the start of the subarrays. And then for each index I, subarray will start from max function 0, comma I minus 1, sorry, I minus nums of I and ends at I. Then we have to increment the prefix sum at the start of the subarray. That is max of I minus nums I comma 0 and decrement right after the end. Like we have to decrement it simultaneously right after the end I plus 1. Then we have to build overlaps. We have to compute the cumulative sum to get the exact count, how many times each element will be included. And then we have to finally calculate the sum, which is multiplying each element, like how many times it's occurring, and then sum up all of them to get the total sum. So for this, first we are gonna create a class solution and a function by name subarraysum, which is already given. Next, we are gonna use a for loop to iterate over range n. Then we are again gonna run the same for loop to get the sum, and then we are gonna return the result, like the sum result. So we'll go to the code. This is the given class, this is the given function. Now, n is equal to length of nums. What is this? This is the length of array. This is the length of array. Next, result is equal to, here, as I said, we have to initialize an array of size n plus 1 to store prefix sum. So this is the initialized array. This is the initialized array. Going on, the first for loop, it is to build the prefix sum. It is to build the prefix sum. And the second one, here, the result max I minus nums I comma 0 plus is equal to 1. This is used for incrementing at start. Increment at start index of subarray. I'm not writing of subarray because everywhere we are dealing here is of subarray. And the second one, result I plus 1 plus, result I plus 1 minus equal to 1. This is basically decrementing after n. So yeah, going on, for I in range n, the second for loop. Here, the first one, result I plus 1 plus equal to result I. This is to maintain the sum, the cumulative sum, the counts of cumulative sum, cumulative sum. And then the last one, it's obviously calculating the total sum. Total sum. As I told, multiplying the element with how many times it's occurring. We have to calculate the total sum. Now we'll run this code. Okay. It's accepted in the given test cases, trial test cases. Now we'll submit it. And it is accepted. The time complexity of this is gonna be, anyone in the chat, do you know what is the time complexity of this? Yes, what is gonna be its time complexity? So the time complexity is gonna be O of n, because initializing the array will take O of n, as well as the first loop will also take the same O of n, and the second loop is also gonna take the same O of n, and also for the calculation of sum, it is gonna be O of n. Since like all of these operations, it is gonna be in O of n, the time complexity of this particular code is gonna be O of n. And also the space complexity of this is gonna be O of n, because the additional space is used. There's an additional space used for prefix sum, the result of size n plus 1. So this will lead for the time complexity of O of n. So we are done with our first question. Anyone, are you having any doubts? So okay, we'll go to the second question now. The second question. 3428 maximum and minimum sums of at most k subsequences. You are given with an integer array nums and positive integer k. Return the sum of the maximum and minimum elements of all subsequences of nums at most k elements. A non-empty subsequence is an array. They have given the definition that can be derived from another array by deleting some or no elements without changing the order of the remaining elements. For example, if 1, 2, 3, then if we just remove 2 there and we have to get 3, then it's gonna be 1 and 3. So this is what is the subsequence. So we'll go to the example here. First example, input nums. Okay, since answer can be very large, we have to return it modulo of 10 power 9 plus 7. Okay, we'll go to the first example. Input nums equal to 1 comma 2 comma 3 and k, the value of k is equal to 2. Now we'll see this. Now given the output as 24, we'll see how. Subsequence of nums with at most 2 elements are. So what can it be? What can it be subsequence? First one, when it has only one, minimum is gonna be 1 and maximum is gonna be 2. Sorry, minimum is gonna be 1 as well as the maximum is gonna be 1. So the sum is gonna be 2. Next, for 2 it is 2 and 2. The sum will be 4. And for 3 it is 3 and 3 respectively. So it is gonna be 6. And for 1 and 2, minimum is 1, maximum is 2. So the sum is gonna be 3. And for 1 and 3 it is gonna be 4. The sum, and for 2 and 3 the sum is gonna be 5. Now we'll make the sum of all the things. 2 plus 4 which is 6, 6 plus 6 which is 12, 12 plus 3 which is 15, 15 plus 4 which is 19 and 19 plus 5 which is 24, and that is our output 24. So anyone in the chat, like, which approach can we use to solve this question? Anyone in the chat, which approach we can use to solve this question? Okay, we'll see. This problem, we have to calculate the sum of maximum and minimum elements here with possible subsequences and with most k elements. Like for example, the most elements that can be used to create it is given through k. Here it was a array of 3 elements, but the maximum we can use is 2 elements. Now, how we can do this? For this, first we have to use factorial pre-computation. Like we have to pre-compute the factorials, and also we have to calculate their modular inverses. We have to pre-compute the factorials and the modular inverses so that we can calculate the combinations. Yesterday I had told we can use a inbuilt function com. Now we'll see this code, and then in the second step we'll be doing modular exponentiation. Here what we are going to do is this code is going to use modular exponentiation to compute inverse factorial using Fermat's little theorem. This Fermat's little theorem. It's very essential when we are solving any question which is having modular arithmetic or modular operations. So here we'll calculate NCR, or the number of combinations, under modular operations. Now, going on to the third step. The third step is gonna be counting the subsequences. First, we have to count the subsequences. For each element in the sorted nums array, the code counts how many times it appears as the minimum or maximum in all possible subsequences of length at most k. So we have to check how many times the code will actually, like, we have to count how many times minimum or maximum is appearing, and finally we have to do the summation. uh, to return the result we have to add all the frequency of minimum and frequency of maximum, and we have to multiply it by its value. For example, here 1 and 1 2 and 1 is coming again, so we have to just make the sum of all. This is the final summation step. So we'll see the code. So for this, we'll make a modulo value, so that it will avoid the overflow. And then we'll make factorial, an array to store factorial value, and next an array to store inverse factorial value, inv fact, inverse factorial. This is for inverse factorial. Inverse factorial, for storing inverse factorial. Now we'll call a static method, and in that we'll call a function called fill to fill the factorial and inverse factorial. This is to fill fact and inverse fact. Okay. Next, we'll do this solution dot fact of 0 is equal to 1. So what is this? The factorial of solution dot fact is equal to 1. Then we are gonna run a loop here. For I in range 1 comma length of solution dot fact. So from 1 to we have already like we have given the fact solution of factorial array at the index 0 is gonna be 1. So for the remaining, for I in range of 1 comma length of solution, for example, if we take the length to be n, already we have calculated what is the solution when the array's index is 0, it's 1. So now we have to calculate the rest. So the range is gonna be from 1 to length of solution dot fact. Now, for this, for this, then we are gonna go to the solution dot fact of -1. This is for inverse factorial. The same again is equal to solution dot mod power. This is modulus power, modulo power, and again modulo power -2 comma solution mod. Again we are gonna run another, like this for loop is for inverse factorial. Here solution dot inverse fact I is equal to solution dot inverse fact I plus 1 into I plus 1 percentage. Percentage is modulus. Modulus dot modulus solution dot mod. Next, we'll call another static method. Define mod power base exponent comma modulus. Modulo value. Here result is equal to 1. We'll just declare result is equal to 1. So this thing, mod power, define mod power. We have used this function to compute base power exponent modulus so of MOD. Base power exp modulus MOD using binary exponentiation. So this is base modulo of mod. Going ahead, we'll call one more static method and there one more function. This is NCR, calculating the number of combinations. Combinations. For this, we are using the NCR. We all know. We'll run a, we'll just return the factorial into inverse factorial modulus solution dot mod into solution of inverse factorial of n minus r modulus solution dot mod. This is what we are gonna use here. NCR is gonna give us the combinations. Next, we'll create one more function. We'll create one more function, count. Here to count, we'll create one more function, count. This will sum the number of ways to choose I elements from n for all I from 1 to k. Number of ways sum from 1 to k. Of I from 1 to k. Next, we'll go to the very important function now. Define min-max sums. And here it has three variables, self, nums, comma k. If now we'll compute it. If the factorial and inverse factorial arrays, we are initializing the arrays here. We are actually initializing the factorial and inverse factorial arrays here. Then nums dot sort. Here we are gonna sort the array for efficient minimum and maximum. This is basically array dot sort function which we use in Python or any other like Python or Java. So this thing is gonna be like using tim sort. I explained in yesterday's stream also. Tim sort is gonna run with O of n in the best time complexity and O of n log n in remaining all the cases. So here we'll use nums dot sort the and this is gonna sort the array so that we can get the efficient minimum and maximum calculations. Now result is equal to 0, just initializing the result. Here comes the very important for loop which we are gonna use. For I in range of length of nums, we have to use a for loop from for I in range length of nums. For example, index of 1 to n. We'll consider the length as n. What it should do, length is equal to length of nums minus I minus 1. This is, what is this? This is the remaining length after current elements. So this is gonna be remaining length after current element. And going on to the count, it counts the count is gonna count the subsequences here, and it will also include the current element here. It is gonna count the subsequences here. And next thing, result is equal to, okay, here we are gonna use result is equal to result plus nums of I into count modular solution dot mod modulus solution dot mod. Here we are gonna add the contribution to minimum. Add country to minimum. And in the second one, we are gonna add it to max. Add country contribution to max. And then we are gonna return the result. Return the result as integer. Result as integer. So this is gonna be our code with all proper explanations here. Now we'll run this code to check if it works. It works for the given test cases. We'll check if it works for all the other test cases. We are gonna submit it. Okay, it runs perfectly fine. Now, what is it? Time complexity and space complexity. Anyone in the chat, what is its time complexity and space complexity? The space complexity of this is gonna be O of n because factorial arrays will also, two arrays are there, factorial and inverse factorial. They are gonna use O of n, and also the total is gonna be O of n itself because the additional space is again used for sorting and it's also in O of n itself. Now going to the time complexity. For pre-computation of factorials, it's gonna take O of n, and sorting it's gonna take O of n log n. I said Tim sort O of n log n, and then counting the subsequences, it's gonna take O of n cross k, and so the overall time complexity of after we combine all this, it is gonna be like this. O of n plus O of n log n plus O of n into k. If we simplify this, it's gonna be O of n log n plus n into k. And here in the constraints, they have given that the maximum value of k is gonna be 100. So you guys can see the maximum value of k is gonna be 100. So we can, if we ignore it, considering the other larger values of n, the time complexity of the total time complexity will be O of n log n, considering the dominant term n log n. So yeah, this is the second question, maximum and minimum sums of at most size k subsequences. If anyone has any doubts, you can please ask in the comment section. Okay, so we'll move to the next question. Paint house 4. Okay, so 3429 paint house 4. You are given an even integer n representing the number of houses arranged in a straight line and a two-dimensional there's a two-dimensional array cost of size n into 3, where cost ij represents the cost of painting house I with color j plus 1. The houses will look beautiful if they satisfy the following conditions. So there's the condition for the houses to look beautiful. First one, no two adjacent houses should be painted the same color. Houses equidistant from the ends of the rows are not painted the same color. For example, if n is equal to 6, houses positioned at 0, 5, 1, 4, and 2, 3 are considered equidistant. Return the minimum cost to paint houses such that they look beautiful. So we'll go for the constraints. N, like the length of the array, is gonna be 2 to 10 power 5. N is even number. Cost cost dot length is gonna be equal to n, and cost of I dot length is gonna be 3, and cost of I comma j is gonna be lesser than 10 power 5. So if we go ahead, we'll go for the first example. Input n is equal to 4 we are taking here. So yeah, the first row it has 3, 5, 7, second 6, 2, 9, next 4, 8, 1, next 7, 3, 5. Now we'll go for the explanation first. So the optimal painting sequences for this is gonna be 1, 2, and 3, 2. And the cost for this is gonna be 3, 2, 1, 3. This is gonna satisfy the following condition. How? No adjacent houses are gonna have same color. Houses positioned 0 and 3 are equidistant and are not painted with the same color. Houses positioned 1 and 2 are equidistant from the ends but not painted same color. Minimum cost for painting these houses is gonna be 3 plus 2, which is 5, 5 plus 1, which is 6, 6 plus 3, which is 9. So for this question, they are asking us to find what is the minimum cost to make houses beautiful. So yeah, what is gonna be its intuition? It's very obvious that we are gonna use a dynamic programming, and we'll choose the minimized cost of painting the houses. We can split the problem into pairs of houses that are equidistant so that we can actually simplify the conditions check, and we'll make sure that the state of DP involves index of the houses. Now, what is the approach? The approach is gonna be DP state definition. We have to define DP state, DP of, we are gonna define a 3D DP actually, three-dimensional dynamic programming array. DP of I, PL, and PR represent the minimum cost to paint from house I to the last house, given that last house on the left is PL and the last house on the right is PR and are painted with certain colors. Now we'll then initialize the base case when all pairs are painted so that the cost is zero regardless of the last painted colors. Then we have to do transition here. For each pair of houses, consider all color combinations. For the current pair that do not violate the conditions, we have to update the DP table with minimum cost using these following combinations. And finally, we have to return the result, which will be found at DP of 0, -1, and -1, which considers that painting all the houses from the first pair. So I guess you're all clear with the question. We are gonna solve we are gonna solve this question now. So yeah, we're gonna go to the code. Here you go. Now, the first will define a solution class which is already given. Then the pre-given function, main cost. Now we have to initialize a 3D DP, 3D dynamic programming array, and also to paint houses from I to minus n minus 1, and last painted house on the left is given by PL. Now we'll go to the first for condition. PR in range -1 comma 3 and PL in range -1 comma 3. What is this gonna be? First case. This is the base case where already all the given houses are beautiful. Here's the definition. No adjacent should be painted with same color and they should be equidistant, and when they are equidistant they should not be painted with the same color. Two conditions. Equidistant should not be painted with the same color and adjacent should not be painted with same color. So yeah, this is the base case where all are already beautiful. And here the cost is gonna be zero regardless of how many houses or how many last colors are there. Now we'll go to the second the second place where we are gonna use another loop. This loop is for second last house pair to the first pair. Second last house pair down to last, sorry, to the first pair. In the second one, PL is for previous left hand. This is for previous left hand, previous right, previous left and previous right. So after this thing for F in range 3, what is this? This is to iterate over color choices for current left and right houses. Current left and right. current, right, and left. Sorry, it's actually left and right. So F is for current left and S is for current right. Now the final condition. Here we are giving a conditional statement where we are determining where it's not equal to what should be returned. We are defining the condition here basically. Beautiful houses. Beauty house condition. And then the DP is gonna return us the value and this is gonna be our result. So we'll run this code and check if this works. So this is accepted in the given test cases. So we are gonna submit this one. Okay. So this code is submitted and it is accepted. So anyone in the chat, what is gonna be its time complexity and the space complexity? Let's go chat. What is gonna be its time complexity and space complexity? Anyone in the chat? What is gonna? I'm making the full code visible here. What is gonna be its time complexity and space complexity here? Okay. The dynamic programming here, it is iterating, like the solution is iterating through half of the houses, which is n divided by 2. And for each pair of houses, it will evaluate the combinations. So there are n divided by 2 pairs of houses. And for each pair, there are three possible colors left house, three possible colors for right house. And there are four possible colors for previous left and previous right. And also a place for no color. So here, what is gonna be the time complexity? It is gonna be O of n by 2 into 4 into 4, which is previous right and previous left with the no color, and into 3 into 3, which is the three possible colors for left house and right house. So this is gonna simplify to O of n into 2 into 4 into 3 into 3. When we take the dominant case, this is gonna be O of n. So the total time complexity is gonna be O of n. This looks like a brute force approach, but no, this is just having the time complexity of O of n. Going ahead, what is the space complexity? A 3D DP table with I, PL, and PR, and size is n divided by 2 plus 1 for number of house pairs and 4 for possible colors and 4 for possible colors from previous right and previous left. So it is gonna be O of n by 2 into 4 into 4. So yeah, n by 2 n. So it is gonna simplify to O of n into 2 into 4, which is equal to O of n. So the space complexity of this is also gonna be O of n. Any doubts in this question for any of you guys? In the comment section. Guys, any doubts for any of you guys? Okay then. So now we are gonna go to the last and the final question of the day, which I guess Leetcode heard me from past 2 weeks, and today they have given the Today they have given actually a very difficult question. Not a difficult question, but a very lengthy question for the fourth question. Maximum and minimum sums of at most k subarrays, similar to the second question. But here, what is the change? Okay. Now change the constraints basically. So if we see this question, you are given with an integer array nums and a positive integer k. Return the sum of maximum and minimum elements of all subarrays with at most k elements. A subarray is they are given the definition of a subarray. It's a contiguous non-empty sequence of elements within a given array. So if we go ahead and if we check the first example, 1, 2, and 3 are the array given array, the nums equal to, and at most we can take two elements. Going on, explanation. They have took one, minimum is one, maximum is one, so it is two. Next for two it is gonna be four, and for three it is gonna be six, three plus three, and then for the fourth case it's one comma two, which is the minimum is one and the maximum is two. And next for the 2 comma 3, minimum is 2 and the maximum is 3, making the sum is equal to 5. Now if we go on to calculate the overall sum, it's gonna be 2 plus 4, which is 6, and 6 plus 6, which is 12, 12 plus 3, which is 15, 15 plus 5, which is 20, and the output is gonna be 20. So the output is gonna be 20 here. And there's one more example with negative numbers. With 1, the minimum sum is 2, and with minus 3, the sum is minus 6. With 1, again, the sum is 2. And with 1 comma minus 3, the sum is minus 2. With 3 minus 3 comma 1, it's again 2. So the output is gonna be what? 2 plus minus 6, which is gonna be minus 4, plus 2, which is gonna be minus 2. Minus 2, which is gonna be minus 4. Minus 4 minus 2, which is gonna be minus 6. So the output is gonna be minus 6. The constraints here, the length of nums array is lesser than 80,000, and k is always in between nums length and 1. So it can be equal to 1 or it can be equal to 80,000 in the max. If the nums length is 80,000, then yeah, 80,000. If not, which should be equal to nums dot length. It can't be out of the range. And nums of I can be in between minus 10 power 6 to plus 10 power 6. So we'll go to this question. What is the intuition for this? This includes similar to the second question, exactly similar except the what you say constraints. But here, since it's a very what do you say like the values are higher, we are gonna use monotonic stack approach to find the next and previous bounds. And also for this, the approach is gonna be like this. We'll create a function gsum. It will compute sum of either minimum or maximum elements. It will use a stack here to determine the subarray bounds, and we'll use two more arrays, nxt and prv, which is next and previous, to store the current element can no longer be minimum or maximum in a subarray. And next, for each element, we have to calculate its contribution to all the subarrays in which it acts as minimum or maximum elements, considering the number of subarrays and also the bounds. The bounds are going to be L width and R width, which is left width and the right width. And finally, we have to compute the sum of these contributions for both the minimum and maximum elements, and we have to finally return their sum. So we'll go to the code here. Okay, we have the code here. So we'll be creating a class which is already given, and also we'll next create a function called define gsum, and then we are gonna create an array. Like we are gonna create an array. Sorry, we are gonna take a variable which is equal to the length of array here, which is n, and then we are gonna take a stack here, and then we are gonna take one more array which is n into n, which is for next and previous, for which it is -1 into n. So this is the next. This is next when condition fails, and the next one is previous when condition fails. It's to store them. I'm not written to store. It's understood. All the variables we'll be using to store or to declare. Now, we are going to our first for loop. Why is this for loop used? This for loop is used for finding the next and previous indexes. So here it's gonna find the next and previous indexes. There's a comparator here. Based on it, it's gonna find it's gonna find the indexes here. Find indexes. Based on this comparator here, which is OP. This is the comparator here. I told in one of my screens, like in my first screen, that what is the use of a comparator? It's gonna compare a array in whichever logic we'll be needing it. We can give the logic for comparing it, and we can give the logic for sorting the array or for sorting the given data structure here. So now, and this is gonna be like giving the index length of stack, and then we are gonna take the result and give it equal to 0. And now we are gonna go to another one for loop. What is the use of this for loop? We have to calculate the sum. We have to calculate the sum which is based on the subarrays, bounds, and the condition. Which is based on subarray, bounds, and condition. So it's done. I told L is equal to what and R is equal to what, and L width and R width. So L width elements to the left, and what is R width elements to the right. Now we'll calculate the contribution. For that, what we are gonna do is result. We are gonna use shorthand here. Result plus is equal to minimum of up plus 1 comma mid into R width plus 1 into array of I. So this will give us contribution of ARRI as a part of subarrays. country of A of I as a part of subarrays. Now, we'll go to the next condition. We'll use a conditional statement if here to give the to calculate the sum based on the subarray bounds here. Again, then we'll return the result here. And now we'll go to the function which was already pre-given, which was define min-max subarray with the variables self, nums, list of integers, and k, an integer variable. And it had to return an integer as the output, which is here. So for this, we'll directly return. So for this, we are directly use the lambda function. You all must be aware lambda function. Like lambda function is used when it will handle both the cases, finding minimum as well as the maximum, without the code needed to be duplicated for both of these operations, and also it will simplify the code. This lambda function here, x, if there is a lambda of x comma y, where x is smaller than y, this lambda function will take two arguments, x and y, and it will return true if x is less than y, and it is used to find minimum elements in subarrays. And next, x comma y, where x is greater than y, this is used to find maximum element in subarrays. So now this is used to return the total sum, return the final answer. This lambda function has a lot of benefits. It has the flexibility. Like we can use different comparison logics without we can. There's no need to modify the internal structure, and also like it will reduce the duplication of the code, and it's also easy to maintain the code base, and also like it will make the code concise, and also it will make sure that the definitions of the functions are small. And finally, this is going to return as the total sum. And we're going to run this code. Okay, this is accepted for the given test cases. We'll see if this will be accepted for the other test cases. We're going to submit it. And here it is accepted for all the given test cases. So what is going to be its time complexity? Anyone in the comment section, what is going to be its time complexity? The time complexity of this is gonna be O of n, because the gsum function, it is gonna take O of n because every element is pushed and popped from the stack once. And the next one, the loop also used for calculating the result is in O of n. So the total time complexity is gonna be O of n itself. Going on to the space complexity, the space complexity is also gonna be O of n because we are using NXT and PRV arrays, and also we are using a stack. So the time space complexity of this is gonna be O of n. With this, the discussion of all the four questions, we are gonna complete it here. If anyone has any doubts, you can please put it in the comment section. I'm gonna reply. Okay, so I don't think so there are any doubts in the comment section. With this, we are gonna end today's stream. Thanks for everyone who joined. Bye guys, have a good day.